We've all been there, right? You see this state-of-the-art machine vision system. It looks incredible in the demo. But then you get it on the factory floor, and it just falls flat. If you're an engineer or a plant manager who is just so tired of this broken promise, well, you are in the right place. In this explainer, we're going to break down exactly why this happens and, way more importantly, how to actually fix it for good.
Man, does this sound familiar or what? This quote just gets right to the heart of the frustration. You've made this huge investment, you've put in the time, but you end up right back where you started, with muted alarms and a quality control process that's still relying on manual checks. It's a pattern we see in factories all over the place. So why? Why does this keep happening over and over again? It's rarely about bad technology, and it's definitely not about bad intentions. The gap between that slick sales pitch and the messy reality of the plant floor, it's usually caused by a few specific, really predictable problems that just get overlooked way too often. And that brings us right into our first section, the broken promise. Here, we're going to dig into the massive difference between what machine vision is supposed to do for you and what it actually ends up doing in the real world. On paper, the business case is always a total no-brainer, right? You're promised better quality, fewer defects slipping through, and perfect traceability. But the reality? Oh man, it becomes this constant headache. Engineers are endlessly tweaking settings, the system starts rejecting perfectly good parts, and pretty soon the operators get so frustrated they just turn the whole thing off. So what's causing this massive disconnect? I'm telling you, it's not just random bad luck. It turns out there are 5 major culprits. I call them the hidden killers that quietly sabotage these projects after they go live. Let's uncover them. Yep, 5 key factors that can turn a super promising automation project into a maintenance nightmare. And you know what? Understanding them is absolutely the key to avoiding it. Okay, first up is what we call environmental drift. See, a lab is clean, it's stable, it's perfect. A factory floor is, well, it's not. We're talking about dust, oil mist, constant vibrations, big temperature swings. Over time, all of these real-world conditions just slowly degrade the system's performance, which leads to inconsistent results and, pretty soon, a total lack of trust from your team. Next up is lighting, and honestly, this might be the single most underestimated factor in all of machine vision. A tiny little shift in the ambient light from the windows, a little bit of glare from a new batch of material, or even just a change in packaging color. Any of that can be enough to completely throw off a finely tuned algorithm. It's that sensitive. Killer number 3, rigid logic. You see, a lot of these systems are basically hard-coded for one specific part under these perfect, ideal conditions. But modern factories need to be flexible. You're running more SKUs, you've got frequent changeovers, and when that vision system can't adapt easily, every single new part becomes its own painful little mini project. Then there's what I call the tolerance tightrope, and it is a tricky balance. If you set your system to be too forgiving, you start letting bad parts escape out the door. But if you make it too strict, you end up scrapping perfectly good products, and that costs a ton of money. Finding that sweet spot is tough, and it's even tougher when your materials and your processes are always changing. And the final hidden killer is all about the human factor, knowledge silos. You know the situation. There's that one engineer, that one person who really understands how the vision system works. If they go on vacation, or worse, if they leave the company, that system becomes a black box that nobody dares to touch. And just like that, your entire investment is at risk. Okay, so we've identified all the problems. That's the heavy stuff. Now let's pivot and talk about what success actually looks like. Because if you ask a plant manager or an operations director what they really want, they're not going to ask for more algorithms. They ask for business outcomes. And this is so crucial. Leaders aren't asking for more complexity. They want stable, reliable systems that don't need a babysitter. They want easy changeovers between SKUs. They want their own technicians to feel empowered to manage the system, not a dangerous dependency on a single expert. And at the end of the day, they need a predictable return on their investment and data that actually helps them improve the whole process. So to get those outcomes, maybe we don't need an even more complex, high-powered camera. Maybe for a huge class of these common problems, we need a different kind of tool entirely. A simpler, smarter sensor that's actually designed for the factory floor, not for the lab. And that tool is the profile sensor. Now, instead of capturing a full, complex image with tons of data, it generates a simple 2D profile. Think of it like a perfect silhouette of your part.
It uses that clean data to take incredibly precise measurements. It's a specialist, and it's built for checking things like edges, positions, widths, and angles. And this table here just illustrates the difference perfectly. A general purpose camera, yeah, it's powerful, but it almost always requires custom coding and a specialist to maintain it. A profile sensor is focused. It's designed for configuration, not coding, which makes it absolutely perfect for those specific profile-based jobs and way, way more technician-friendly. So what makes this approach so plant-friendly? Well, for one, modern profile sensors can handle multiple measurements all at once in a single device. They use a simple browser-based setup. It feels more like managing a recipe than writing a line of code. They are completely optimized for the exact positioning and dimension checking tasks that cause so many headaches, which ultimately saves a ton of precious engineering time. So, how do you actually put this into practice? How do you make the shift from a risky science experiment to reliable, everyday standard work? Well, there's actually a clear path to get there. Here it is. This is your 5-step blueprint. Step 1. Just identify one nagging problem, a station that has chronic manual checks or constant rework. Step 2. Ask yourself, is this problem fundamentally about edges, positions, or dimensions? If the answer is yes, you've got a perfect candidate. Step 3. Run a pilot with a configurable profile sensor. Step 4, and this one is critical, document everything from day one. Turn that tribal knowledge into a standard procedure anyone can follow. And finally, Step 5. Once that solution is stable and proven, you scale that success to the next station. So that really leaves us with this one critical question for your next automation project. Are you building another fragile science experiment that only works when one expert is standing over it? Or are you building repeatable, technician-friendly standard work that's going to deliver value for years and years to come? Honestly, your answer to that question will determine whether you're creating another problem or a lasting solution.